Boom. We're live.
Wow.
All right. I'm super run down today, and I don't know why. Slept like garbage.
Sorry.
But I'm enthusiastic to talk about calculus. And look how little I have to erase from the board.
That is something else to be excited about.
So we've run into this weird issue because, whoa. They're totally going to tag me for that. I think you should be allowed to have 15 seconds as a lead-in. Fair use doctrine. Yeah, so we're exploring the non-functions in Honors Algebra 2. The problem is you can just type x squared plus y squared equals 25 into Desmos, and it'll just make a circle for you. So all of the exploration, I have to start by saying, okay, everybody close your Chromebook. No looking at Desmos. And then when I go to have them type it in, we do the solve for y thing. Okay, now I want you to type in this equation here, y equals. And then I walked around and some kids got x squared plus y squared equals 25. I said, what did you not understand about do not type in x squared plus y squared equals 25 into Desmos? Oh. All right, guys, what questions have you got about calculus for me today? Yes. 4.4?
Yeah.
Radioactive decay. A equals 20 times 1/2 to the t over 140. Find the rate. At t equals 2 days. Okay. What do you know immediately?
It's like the natural logarithm signs. I just didn't know if that was the right way to do it.
So does this look like some function raised to the power of another function? Or does it look more like that? So logarithmic differentiation is not appropriate because we don't have a function raised to the power of another function. Now, could you do logarithmic differentiation? Sure. I mean, if you wanted to do logarithmic differentiation, so we have natural log of a equals natural log of 20 times 1/2 to the t over 140. But here's the problem. There's not a thing I can do with this because my natural log rules don't allow me to do anything if that 20 is there. Or maybe I can use the product. Is this natural log of 20 plus natural log of 1/2 to the t over 140? All this doesn't help me. It's just complicated. So misapplying the natural log or the log differentiation just makes your life harder. Because now I've got, I mean, I can still do this. What's the derivative of that? 1 over a. Chain rule? times what? Derivative of natural log of 20?
120.
Everybody see the problem? Is natural log of 20 a function? Or is it a number?
Number.
What's the derivative of a number? 0. This is not a function. No variable. Derivative of natural log of 20 is 0 because it's just a number. It's a constant. Now, I could take the t over 140, but you see how complicated this has gotten? As opposed to what do I do with the constant in front of a function, but when I take the derivative? I just leave it there. So I just leave the 20 there, and then it's the derivative of that. And what's the derivative of that? What's the derivative of this?
Something. Yeah, it's E.
Natural log of times not and then yeah, the derivative.
What's the derivative of t over 140? Yeah. Wait, what?
Times 140.
There's your answer. Plug in 2. Because all this becomes super, super important. It's sort of like the whole, what's the derivative of t over 140? And saying, oh, look, a quotient. Because you could say, well, u is equal to t, v is equal to 140, the derivative of u is the derivative of t, the derivative of v is 0. So the derivative is v du, which is 140 t prime, minus u dv, which is t times 0, divided by 140 squared. But why? Now I have to simplify out one of the 140s crosses off, and I get 1/140th times the derivative of t. Well, why wouldn't you just say that divided by 140 is a constant, and so you have 1/140th times the derivative of t? Well, that's, oh yeah, because what's t prime? T prime is 1. So actually, I even made that even more complicated. Every time you were asked to find a derivative, you should stop. Take a second to go through the different possibilities in your mind. What kinds of things, what kinds of strategies do I have? If it is just the derivative of some function, you can either use a shortcut, or you could use the definition of derivative if you don't have a shortcut. If it's sine, well, then you know it's cosine. But if it's some function you've never seen before, then you use definition of derivative. If it's composite function, then use the chain rule. That's a C. If it's a function to the power, you use logarithmic differentiation. If it's something to a power, well, then you got a shortcut. If it's something raised to a power, then you use the power rule. If it's a quotient of functions, you use the quotient rule. Don't rush into the first thing you think of when you're asked to find a derivative or you're given a problem that says, what is the rate of change? Stop, analyze the function, decide what kind of function it is, and then decide what rule you're going to have to use. This is a great example of the constant multiplier rule. If there is a number out front, stop, move the number out of the way, then take the derivative of what's not the number, what's left. All right? Okay, more questions. I love how all these questions lead me into big philosophical instead of just answers to questions. Teresa.
Number 65.
Number 65. Number 65 says, which is bigger, pi to the e or e to the pi? You can answer the question without a calculator. Okay, so the graph of y equals natural log of x has slope of 1 over e. If we're looking at the tangent through the origin. Agreed?
Yep.
Find an equation for the tangent line. Okay, well, y equals 1 over ex. Because it goes to the point 0, 0, agreed? Give an argument based on the graphs of y equals natural log of x and the tangent line to explain why natural log of x is less than x over e for all values, for all positive x, not e. Are you okay with that argument? Okay, I mean, there's natural log of x, there's x over e, and that's less than that everywhere except for right there at that one point. Okay? Show that x to the e is less than x. Aha, algebra. I want to show that x to the e is less than x. I'm starting with this. What can I do with that? Let's try solving for x. How do I solve for x? Multiply by e. E to the natural log, or e times natural log of x is less than x. Agreed?
Yep.
Now what? Log properties.
We can put the e as x to the, like, that's why x to the, yeah.
Now what? Because that's not what I was asked to show, but what do I know about natural log of x to the e? Is it less than x to the e? How do I know? What do you mean by they cancel each other out?
Natural logarithm.
No, e to the, I mean, it's a good thought, but you're thinking of that or of this. So how do we get from here to there?
Wait, why is the x raised to e on the right side now?
Beats the heck out of me. Oh, because I'm not interested in x.
Yeah.
So if I can show, okay, here's what I was thinking. If I can show that, then this must be, I've already shown this, agreed? If I can show that this is in between them, then that must be less than that. So that's sort of where I was going with that. And maybe I went a step too far too fast. But how does this help me show that? What is the relationship between natural log of e to the x, x to the e, natural log of x to the e, and x to the e? Thank you, Claire, for getting e to the x in my head. What's the relationship? Is there one? Oh, well, I wrote down that problem wrong anyway. None of you caught it. That's not what the question asked. And I don't have my glasses on for one. That's an excuse, not a reason.
Oh, don't do that.
Oh, look, we just did it.
What would you have done if it was?
Show the other one? I don't know. I mean, I honestly don't. I mean, it was one of those things where, okay, well, what do we do now? And guys, this is everything so far on this question is just comparative. If you have a function, I mean, we proved that this was true right here. Well, I didn't really prove it. We looked at the graph and we claimed it. Mathematical proof requires a little bit more. But it doesn't say prove, it says show. So, that's a different question. And so then, starting with what we knew, so this was what? That was B. So B led us to C. So now let's look at D. What does D ask us? Conclude that x to the e is less than e to the x. Claire, what did you say earlier? Because it's just become relevant. Think about what they're asking us. They want e to the x. How am I going to make this side into an e to the x?
Raise both sides.
Raise both sides as powers of e. Agreed?
You did again.
Claire, Help me out. What did you say that was relevant? Yes, they do. Look at that. Those cancel out because e raised to the natural log. X to the e is less than e to the x. For all x, not e. And obviously they're equal for x equals e. So which is bigger? Pi to the e or e to the pi? How does that relate to this problem? Well, you've just proven, you've just shown, we'll get people like Mr. Brannon mad at us by using the word proof inappropriately. We've just shown that x to the e is less than e to the x.
You substitute pi for e.
So now let's substitute pi for e. So 3.14 to the 2.71 is less than 2.71 to the 3.14. Is there an approximately less than? I'm a little concerned that that's not true, unless you take it to more decimals, but I'm willing to go out on a bit of a limb here and just say yes. Which is sort of an interesting question. So I mean, the question is why would you care? But I think it's just sort of interesting when you get to this is you take two numbers and flip them in a power. Where is the boundary? I mean, 2 to the 4th and 4 squared? Or one less than the other?
No.
No, in this case they're equal, right?
Yeah.
How about 3 to the 4th and 4 to the 3rd? $81.64, right?
Yeah.
How about 5 squared and 2 to the 5th?
This is probably bigger.
25.32. 5 cubed and 3 to the 5th. $125, 243. I mean, that's an easy one if you just remember that 3 to the 4th is 81, which is one that should always be in your head because now you're just multiplying 81 by 3. You don't actually have to do 3 to the 5th. You just have to remember that it's 81 and then one more. So there doesn't seem to be a pattern here, but I don't know. It's sort of an interesting. I bet you there's a whole research department at some math university where some grad students sitting around doing weird calculations to try to see if there's some kind of pattern. Or maybe they already did it and we just don't know about it because we're stuck here at a high school not doing anything interesting. You know, going to football games and.
The difference is actually about like 0.67 between.
So less than 1?
Yeah.
How many, did you just type in pi and e as opposed to decimals?
No, I did it the way you did it.
Gotcha.
Just 16.
Gotcha. Interesting. All right. Yeah. Huh. Rabbit holes. This is one of the things I like. You know, the fact that we're not focused on the AP test, I get that there are good reasons to take the AP test because it gets you college credit, but you don't have time to go down rabbit holes. I mean, if we were focused on the AP test right now, we're not wandering off into little discussions about powers and because it's like, well, that doesn't help us on the AP test. Next. This is more fun. Maybe we should just not have AP classes and then have fun instead. We should have some crazy advanced math class that you take and learn calculus, and then whatever veering off we end up doing. But then people would piss and moan. I can't get my college credit. Ah, just relax. Good Lord, you're 16. You got at least 70 more years to think about college credits. Just ballparking.
I hope not.
You hope not?
I hope I'm not 70 and thinking about college.
Oh, well, you might be. There's all sorts of cool stuff. I mean, I suppose I could tell you guys, you're going to graduate anyway, because you won't be. Oh, well, no, you're not all going to graduate. Okay, I can't tell you how old I am. I lie. Every time the subject comes up, I say something different. It's interesting watching to what extent, what students will believe and what students will not believe. Like a couple years ago, I said that I was 39 and I wasn't looking forward to turning 40. And the immediate reaction from some student was, well, my grandma's older than you. And it's like, or like, my grandma's 39 or something like crazy. Like, no, it couldn't have been my grandma. Was 30. Yeah, I guess it could. Maybe I said I was 44 and my grandma was 44. And I think one time I said I was 30 something and they were like, my dad's older than you. And it's like, but there is a lower limit at which they don't believe me. They think I'm lying. Okay, what else you got? More questions. Oh, I know. I was thinking about college courses. There's a really awesome company called The Great Courses. And they are online college courses about just all sorts of interesting topics. I picked up the one on the development of American popular music, which starts back in the like 1700s and analyzes all the different like Broadway and the slave plantation music, and which then became came into popular culture. It's fascinating stuff. Fascinating stuff. All right. Sorry. Go, math.
What do you take after calculus 2?
What do you take after calculus 2? I strongly recommend calculus 3.
No, what's after that? What's some of your
4.
4?
5. 6.
6.
I mean, I just made up my own numbering system, but what the heck?
Yeah.
No, calculus 1, 2, and 3 are just calculus.
Yeah.
There's multivariable calculus. And multivariable calculus it focuses on sort of three-dimensional and topographical mapping type stuff and how to deal with things that change in multiple variables, because lots of things don't, I eat more sugar, my blood sugar level goes up. That's only 2 variables. The amount of sugar I eat, my blood sugar level, but most things don't deal with that. And there's also, then you just get into things that don't have the word calculus on it, because at some point they assume that everything's got calculus, and so they don't put the word calculus on the end of every class. But mathematical modeling is a cool one. You're going to get, depending on what you want to take, you're very quickly going to be told, okay, here's your list. And it no longer becomes a question of what shall I take next, but the list says, if I'm going to be an aerospace engineer, I'm taking that one next. And then they're not going to even call them math classes at some point. If you're a math major, then yes, you're just going to take math. Well, if you're an engineering major, you're going to take math, but it's all going to be called ENGR in the catalog. It's still math, but they veer off into practical application, and then you can go be a high school teacher and use the word proof inappropriately. Calculus questions: how to do different problems, concepts that you're struggling with. What do I do when Okay. I'm not going to talk about test taking strategies because I also don't care. You don't need test taking strategies if you know all the math really well. There you go. Test anxiety, I think, is not a real thing. I mean, it's a real thing to the extent that it's a real thing to the extent that people think it's a real thing. I don't know if that statement makes sense, but the people that I see coming out of a test having done poorly and then saying things like, oh, I have test anxiety and I never do well in tests. Well, they also don't know the math very well. I use the example that there's not a single person who I have ever taught or known that if you said your grade depends on printing your name on this piece of paper and spelling it correctly, would then spell their name wrong. Oh, but I have test anxiety, because they know how to spell their name. I honestly think that much of test anxiety can be eliminated completely. I'm not trying to be dismissive, by the way, but I think a lot of test anxiety can be eliminated completely by knowing the material better.
Okay, here's this. In Spanish, this has happened multiple times this year. You have a test, you know all your stuff, because I know my stuff. And then you take the test, and then you're like, oh, this one answer, can't figure it out, makes no sense. Literally within like 2 seconds of the test being over, I know what it is. Like this happened probably like 3 times this year. It was sleeping. It just translate I'm sleeping in Spanish. I had no idea what it was.
Yeah.
The test ended. I was like, oh, it's Duomo.
Yeah, but I would still, yeah, okay. I mean, I'll buy
literally within a second.
I'll buy that you're under more pressure when you're taking a test than you are normally. But you also have a limited knowledge of Spanish in that scenario. You are not fluent in Spanish. If you were fluent, if you were taking the same test in English, how do you say I'm sleeping in English? I'm sleeping. Okay, well, there you go. I don't know. It's, again, like I say, I'm not trying to be dismissive, but I think test anxiety sometimes becomes a crutch to justify the fact that you're not doing well, as opposed to saying, clearly I didn't know the material as well as I should have, and I'll spend more time and get off my butt and learn it better. So, there it is. It's also just an opinion, so take it for what it's worth. Everybody gets to have them. Any other math questions? No other math questions? All right. So the 4.4 quiz drops today. I will grade them and get them back to you as fast as I can so that you can take a look at them and review them. Normally I wait till everybody's done with the test before I grade them. I'm feeling a little bit bad about the fact that 3 folks in the other class haven't had the opportunity really to ask me as many questions. So what I will probably do, and I'm not quite sure how this works on Formative, I'm going to try to grade them and send them back to you as fast as you do them. Please don't share them with other people in the class. Don't talk about the quiz. What I may do is I may just download your answers into a PDF and then email them to you so that you can look at them, because I don't think you can look at them in Formative until I close it. Although there may be an option where, I don't know, I'll look, but I'll get them to you somehow so that you have an opportunity to review them. The chapter 4 task, it should be pretty straightforward, guys. It's not going to be anything super complicated. The big thing is going to be to analyzing the functions, like I said before. Don't rush into don't rush into, oh, look, I see a this, and so therefore it must be that. Just pause and think to myself, what kind of function is this? There's only like, what, 4 different options. It's either a straightforward plain old function, a power function, a composite function, or a function raised to another function, which is logarithmic. I think those are the only choices, really. So just don't rush into it. This is a fun word. How do you guys say this?
Composite.
Yeah, is there any other
Oh,
pronunciation?
Composite.
So that's incorrect.
It isn't actually. They're both correct. And part of the problem is that I grew up in Canada, spent part of my youth in England, and have spent most of my adult life in the United States. And I go back and forth between pronunciations randomly. I don't know if you noticed, but today I said that word twice, and I said it once each way. And I've tried to sort of force myself to get in my brain one particular way, but composite and composite, and it just pops out randomly just in a sentence. I don't have any control over how I pronounce that word, which is interesting.
How do you say root and root?
I try not to, because then people mock me. About is another one. People, yeah.
Oh, yeah.
Um,
So I think my accent has mellowed a little bit, but when I was younger, well, especially when I joined the Navy, I was sort of right out of growing up in Canada, and it's out and about. There's this ow sound.
yeah.
And when I was in the Navy, they would bring new guys into the enclosed operating station where I was working, and they'd say, "Lieutenant, say out and about." And the problem is you can't tell them to get out without saying half of it. And so then I would have to remember to say leave instead of get out.
That's funny.
But yes, I left the Navy with a very, I'm good at accents. When I learn foreign languages, I tend to, whatever my flaws in my various foreign languages, accents are not one of them. I can with a modicum of knowledge sound like, if not a native, at least somebody who knows how to speak the language pretty easily. And the problem is, part of that comes from I just pick up and lose accents very easily. And boy, I left the Navy with this weird combination of Canadian, Midwest, Texas, Southern English from living in England accent. And it's interesting, there is, I was reading this the other day, there is a standard US military accent.
Really?
Like, people who are into linguistics can listen to somebody and say, yeah, you were in the military for a while, because you're absorbing little things from all over the country because you're constantly with people from all over the place. And not everybody gets it, but people who pick up accents easily end up with this very standard military accent, which is, it's very sort of Midwestern, but like I say, with Southern, Texan, New England, all sort of like blended into it. And it is interesting because I listen to myself when I listen to my recordings, I go back and I listen to myself. And it's like, wow, that's my accent. And I feel like my accent is very Midwestern. Well, I've never lived in the Midwest, ever. It's the one place in the country I've never lived. I've lived on the West Coast, I've lived in the East Coast, I've lived in the South, Canada and England, obviously. I've never lived in the Midwest, but I have this sort of flat accent that sounds somewhat Midwestern to my ear when I listen back to it. So,
I thought that you like how to from the Midwest, or yeah.
yeah. That's that U.S. military accent. It's very strange. Hey, interesting study. Not something I'd want to do as a job, but very interesting stuff. Any more math questions before I just sort of leave you alone? Like I say, rabbit holes. Oh, look, a rabbit hole. Oh, look, another rabbit hole. Ever seen the T-shirt that says, "I have ADHD, but it doesn't really." Oh, look, a chicken. Fun T-shirt. All right, I'll leave you alone. You can ask me questions individually if you have them. I'm going to shut off the stream. Oh, wait, before I shut off the stream, I should look at Gmail and see if the person watching the stream emailed I hate the fact that I constantly have to log back into my Gmail. We want your mail to be secure. No, you don't. If you wanted it to be secure, you wouldn't use it to sell me advertising. Okay, nope. No questions been emailed to me by the live streamers. I'm also not 100% sure. It says